Good afternoon, and welcome to our webinar, The Rules of the Game on Lithium Energy Storage. My name's Mark, and I'm with Morningstar. It's 2 o'clock in the morning here in the United States, and we're excited to be here. That's how much we enjoy talking to our friends in Australia. On our side, we have Brad Burwald, our product manager and technical training manager. Brad was doing something of everything at Morningstar: sales engineering, technical marketing, training, global account management. So we gave him a real job and made him responsible for our entire product line. We keep him pretty busy. From genZ, or genZ as it's called, our second industry leader, we have Albert Wijaya, business development manager. Albert's been working in the space of industrial battery and solar systems in the last 10 years down under. His current role at genZ is supporting the growth in energy storage market in Australia and beyond. Finally, the leader making the webinar possible is M+H Power, and they're represented by Dale Wilson, their sales director. Dale's been instrumental in off-grid and grid-connected solar distribution for the past half-decade. Before that, he had extensive experience in electrical and telecommunications projects and systems. So just a few housekeeping items before we start. We'll make the presentation available after the webinar so you can review it when you like. In the handout section, you'll find data sheets and information on genZ and Morningstar products covered. Feel free to type your questions in during the webinar. We'll try and answer them all at the end, and if we don't get to them, we can email you answers later. And finally, one lucky audience member is going to get a Morningstar charge controller. At the end of the webinar, we're going to have a random drawing for a Morningstar SunSaver MPPT15L. It's one of the industry's most successful charge controllers, and it's a $425 value, Australian dollars. The only requirement is that you have to be here at the end of the presentation to be eligible for the drawing. So stay with us. It's made possible by M+H Power, who will send the winner their charge controller after the webinar. So with that, I'm going to turn it over to M+H and Dale Wilson and get us started. Thanks again.
Thank you, everyone. Thanks for joining us on this afternoon here in Australia. Next slide, please. Just want to do a quick introduction, a quick cap. M+H Power has been taken over by the Legend Corporation in the last four to 4.5 months. So just wanted to give a quick introduction on who we are. A lot of people knew us from the distribution arm of mPower. Legend's a fairly large organisation, as you can see from this page, that we represented a lot of brands across the electrical, electronics and industrial sort of spaces, and in power and data. For example, we're a manufacturer of fibre optic products as well, that we have been supplying in solar farms and now moving into the distribution of solar products and solutions. Next slide, please. We've got multiple locations around Australia, as you can see, and at a glance, we're a $200 million business with 370 employees. So the benefit that we bring to the old mPower distribution as now M+H Power is a very good backing and support for large distribution and stocking requirements around the country. We have got strategic relationships and partnerships through the electronics and electrical space, and you can see some key names: ABB, Emerson, Honeywell and Fluke, just to name a few of our key partners that we represent in this country. And we're represented along with a lot of our electrical wholesaling product. Our product is through electrical wholesaling chain, which you'll probably see and touch on a day-to-day basis when you're out on the tools. Next slide, please. Here is a quick snapshot of key products. Obviously, genZ and Morningstar are key suppliers of our product range. I won't go through all this one by one because you're not here to listen to me. You're here to listen to the experts on their product on lithium. But you can see mixture of inverters, panel manufacturing. We're very pleased to be continuing the support of Suntech panels, as well as other battery technology. But genZ's our leader in lithium. Next slide, please. What makes us different? This is what we're working hard on here at M+H Power. Yes, we've got some great products to work with and to put into your projects, but you know, we're a design engineering centre. We're very close to releasing, to work closely with our customers out in the market. We have got a big focus on off-grid and solar focus. Not saying that's all we do on-grid solutions, but that's where we're a big focus in and being a leader. We've got our national distribution. We've got 4 locations where we're stocking from Perth, Brisbane, Sydney and Melbourne. And there'll be other locations in the near future as well. And as well as battery cabinets is what we're going to be stocking in a built environment, so they'll be able to be built and sent out to site for our customers. Next slide, please. So this is a quick snapshot, and you'll be able to see this when you download the slides after the presentation. But here's all their contact addresses and contact details. And thank you again for joining. I'll now hand you over to Albert from genZ.
Thanks, Dale. Hi, everyone. Thanks for joining this webinar. My name is Albert Wijaya from genZ Energy. We're headquartered right here in Perth, Western Australia. Today, I'll be sharing our history, our product philosophy, and value proposition. So on to the next slide. We started in 2015 in Perth, but our conception started back in 2014 in partnership with Radling Communication. We realized lead-acid battery was becoming a legacy technology in remote and unmanned sites in the Australian outback. The weight and the short lifespan of lead-acid are increasing the total cost of ownership. There was a need for a new chemistry that can last longer in this harsh environment. Now, back in 2014, if you can still remember, this is way before lithium was fashionable. In fact, this is before Tesla Power was in Australia. In fact, the idea of using lithium as an energy storage was perceived as dangerous and commercially unviable. That is when we began our research, asking the tough questions, braving the trial and error involving various field testing right here in Western Australia. The result of all these activities is our choice of lithium ferrophosphate, or LFP, and designing our own proprietary battery. And that's the beginning of genZ. On to the next slide. Here is a collage of Australian outback to help us appreciate the extreme conditions our batteries were developed for. Now, on the next slide, this is our product philosophy. Our product is designed to last through the extreme weather of Australian conditions with reliability and safety to run critical power systems and longevity that delivers real savings. Now, on the next slide, I'll explain why we choose LFP over other chemistries. Now, this is a comparison table between our LFP versus other popular lithium chemistries in the market. Remember, we design our batteries for Australian conditions in mind, so always horses for courses. First one, thermal management is key for our application, and LFP champions this. In fact, there is no need for active cooling. And LFP is actually fully recyclable. And in fact, if it hasn't been disposed properly for whatever reason, it's not going to contaminate the local landfill. And last 2 points, LFP retained capacity at the end of life, and its cycle life is superior compared to the rest of the chemistries. Now, on the next slide, there are 3 different types of LFP cells. You've got cylindrical, prismatic, and pouch. We use cylindrical cells for 2 reasons. First one, it has the best thermal management in terms of dissipating the heat from inside the cell. Second point is mechanical strength, and that's great for both vibration, but also to withstand mechanical expansion from your charge and discharge cycle. Now, next slide. This is the various testing regimes that our cell has gone through. The bottom line is, guys, that the cell has been abused and it hasn't gone up in flame nor exploded. The next slide, I'm giving you a sneak peek of the inside of our battery. And for your reference, we use the 2650 3.2 volt cells LFP, and we join them in series and parallel to get the desired voltage and current. We actually also implement cell matching during manufacturing to ensure that individual cell carries similar or the exact same voltage and capacity. Next, you'll be wanting to know this, that each genZ battery comes with its own battery management system, or BMS. Our BMS is a self-managed BMS. That means there is no comms layer between the battery and the power conversion system. This enables our battery to be integrated virtually to any systems out there without comms integration roadblock. Also, there is no need to update the firmware of the BMS later on. Now, RBMS provides 5 key features: over-discharge protection, overcharge protection, short circuit protection at 200 amps and they'll trip within 20 milliseconds, over temperature protection at 65 degrees, and active cell balancing. Now, BMS is essentially circuit boards, right? A BMS like ours could cost between $10 off the net to $500. And that's depending on the components that's being used, the workmanship, and thermal management. So rest assured, our BMS is of quality, and the electronics are rated and tested to last in high ambient temperature. Now, on to the next slide. We take pride in this, that we've embedded another layer of protection. In fact, this is now recommended by Best Practice Guide in Australia and part of AU NZS 5139. And that is the built-in circuit breaker for each unit of our rack mount module. We fitted a 60 amp, a 2-pole breaker, compliant to IEC 60947-2. It's worth noting here that we have the circuit breaker 5 years ago, before this is now mandated for pre-assembled lithium battery. Now, onto the next slide. Again, back in the conception of our product, we understand the stigma of lithium battery being associated with going up in flame. And I'm sure you've seen Telstra cars doing exactly just that back then. So to put this to rest, we have put a couple bullets through our battery to check its combustibility. So this test was carried out by Queensland Police prior to using our battery for some of their patrol unit. In the event of open fire, they need to make sure any gunshot will not trigger battery explosion. The picture at the bottom is an up-close look of the aftermath. No flames, the body is still intact, and we've passed the test. This is probably the only lithium battery in the world that has lead in it. In fact, we've still kept this battery to date, and our partner, M+H Power, has this battery with them. So if you're keen and wanted to check out, I welcome you to reach out to them. On to the next slide. This brings us to our offering. We've got our rack mount module, which is our proprietary design and engineering. This comes in 24 3kWh, 48 volt 2 and 3 kWh. Now, our plastic case range, whilst it's not by our design, we prescribe the cell and the BMS used in each battery. They're available in 12, 24 volt and 48 volt, ranging from 7 amp hour to 200 amp hour. On to the next slide. Now, it's all well and good to talk about specification and performance of our battery, but I reckon what's equally important here is how does our battery bring value to you? So on the next slide, I'm going to compare a popular solar battery configuration in Australia, a 48 volt, 1000 amp hour OPZB gel for an off-grid application with an average daily load of 10 kWh. And we'll compare this with genZ, 48 volt, 24 kWh solution. On the next slide, I've got a comparison table and we'll go through it line by line. So if you notice that genZ total capacity is just half of the gel battery, but we offer 35% more usable capacity thanks to 80% depth of discharge. Our solution offers 70% reduction in weight. Well, this equates to less transportational costs, less back pain for the installer, and perhaps less slab for that foundation. There is a 50% improvement in both warranty and cycle life. Now, equalization. It's a bit of a taboo word here. In my experience, most lead acid battery die prematurely in off-grid because they just don't get equalized ever. Well, this is not a problem with genZ, as LFP chemistries can operate in partial state of charge. Now, if you look at the last line, it's the retail price for these two solutions. That are merely 20% premium, genZ solutions exceeds in value well over the additional 20% price. Now, that's the comparison with lead acid and genZ, but how do we stack up with other lithium offering in the market? Now, this table includes popular lithium offering in Australia. They are generally LFP chemistry with an exception of the L brand. Price per kilowatt hour retails between the low $900 to just over $1,000. When it comes to warranty period, mostly they're offering a 10-year full warranty with an exception of brand L and P. They're offering a 2-year full and 8-year performance warranty. What's interesting is that what coverage do you get within this warranty period? And this is where the energy throughput comes in. genZ being an unmanaged lithium, we provide a 10,000 cycle warranty at 80% depth of discharge. Other lithium offering hovers between 3,000 to 4,000 cycles. Continuing from energy throughput, let's compare the warranted retained capacity at the end of warranty period. Our battery specification retains 80% of its original capacity. However, for commercial purposes, we only cover 70% retained capacity. But then if you look at the other brands, they're sitting at just 60% retained capacity. So you're looking at about 10% gap there. Now, if you look at the last line, dollar per kilowatt hour per cycle, are also referred as levelized cost of energy, LCOE. genZ offers the lowest LCOE, and that's between 55 to 70% cost reduction compared to the rest. Ladies and gentlemen, this is how genZ provides value through its longevity of the product. Now, let's have a break about it. It's enough about genZ for the time being. I'm going to hand the time over to Brad at Morningstar. Over to you, Brad.
Okay, great. Thanks very much, Albert. And I really appreciate both you and Dale, all of us teaming up together for this presentation, and a regional centric webinar is a really great chance for all of our companies to get together and talk about off-grid and battery storage. So a little bit about Morningstar. Again, to introduce myself, my name is Brad Burwald, as Mark had said, in product management. So dealing with many of the technical marketing and working with engineering on product development. So I wanted to give you a little bit of background on Morningstar if you're not already familiar. First, 4 million products installed in the field since '93 when the company was conceived. And we have global reach over 100 countries where we represent mostly battery charging and inverter products in mission critical applications. And we've got a pretty diverse area of expertise in residential, rural electrification, commercial, and a variety of industrial and telecom applications. And we like to think of ourselves as the charging experts when it comes to the choice of battery settings for a product. And also in terms of hardware failure rate, we are proud to say that we have some of the lowest in the industry. So one of the things that really helped us to move in the direction of the Energy Storage Partner Program was that a couple things have changed in the transition to a lot of lithium support in the market. First is 30% of our inquiries are about the use of lithium in remote solar and especially in off-grid where we focus, and they want to know how to make sure they can get the extended cycle rating and dealing with the state of charge impacts of these batteries. And one of these common requests from our customers is they ask us all the time in surveys and through a variety of channels is how can we get manufacturer vetted settings? In other words, Morningstar, can you partner with battery companies and really see eye to eye and get agreement on the settings that we need to use for our batteries? So what we do is we work with those companies, and that's where the Energy Storage Partner Program began. So with that, we work closely to get the compatibility and operability of the products defined up front. We make that available on our website through a variety of technical documents, and this helps make installation easier. And lastly, we give a very well-documented, proven settings, in some cases even giving you the configuration files themselves for these batteries. And that's been reviewed by the battery partner and by Morningstar's engineering and application support team. So with that, we have a wide variety of products that can actually be customized. These are all our programmable products in both the PWM and MPPT categories. So all of these products can receive our configuration files that I'll go over a little bit later in the presentation and can be fully compatible with lithium batteries. Some of the specific features we've been incorporating in the latest products that we've gone onto the market have been specifically for some of the finer points of lithium battery compatibility. So I'll talk about just a little bit of those here with you on the webinar today. The first is we do offer a what we call lithium foldback, which is done at low temperatures. Now I know this is not too much of a challenge in the Australia region, since you've got generally a nice warm climate. But in areas that we do sell into, and North America and other regions, specifically Canada, we do see colder temperatures. And while lithium generally provides very low power, very low temperature ratings, it can still deliver power. it often cannot be charged at those cold temperatures. So if you do exceed those ratings, the controller will automatically reduce current in order to make sure that the battery is charged correctly. We've got interactive meter display options, so you can adjust those settings very easily. We have remote temp sense, so we're getting a temperature right at the battery. Everything is programmable very easily using our software via USB port. And lastly, as you'll see with a lot of these batteries, they have a much flatter voltage profile. So voltage sense really gives the controller the ability to get the most accurate voltage rating right from the battery posts. And that's going to go around any kind of terminals or voltage blocks or fuses that might interfere with that. So we get it right from the posts on the battery, and that ensures proper charging. And then lastly, you will see, of course, on all of our products that are MPPT controllers, our TrackStar MPPT algorithm, and that generally provides excellent tracking, very fast recognition of power points, and it's going to give you maximum output delivered to the battery, regardless of the types of solar insolation levels that you're seeing. Okay, and you can read more about that on our website. We've got a variety of technical documents. So a little bit of an intro on Morningstar there and our line and talking about ESP. I will now hand the slide back to Albert so he can cover a little bit more about some of his lithium applications experience with a few system case studies.
Perfect. Thanks, Brad. Now, before we go into case studies, I'm just going to give you a few recommendations when you choose your next lithium batteries for your off-grid system. First one, check if the lithium meets appropriate Australian standards. There should be an icon coming up. Thank you. Number two, make sure you fit the right lithium battery for the right application, because not all lithium batteries are built the same. And it's always horses for courses. Number three, read their warranty statement meticulously and ask questions. There is a very clear distinction between a full warranty and a performance warranty. Point number four, check if they have an Australian support now and hopefully into the future. Ideally, the manufacturer needs to have an Australian office, because ultimately, they are the one who will support the warranty when the installer is no longer in business or has moved to another city, and you don't want to be left alone. Second last point, if the price is too good to be true, it probably is. There are ways to reduce $ per kilowatt hour by using lower grade cell and BMS. The bottom line is it's not worth the gamble. And last point, if you're going to go with managed lithium battery, you'll need to update the firmware sooner or later. So if you're an end user, ask this to your installer and make sure future firmware upgrade doesn't cause you an arm and a leg. And if you're an installer, get the assurance from the manufacturer of their ongoing support. Now, on to the next slide. As the saying goes, guys, the proof is in the pudding. So in the next few slides, I'll be showcasing where our batteries have been deployed right here in Australia. So, hang on, back to the previous slide, please. Okay, so this is a site in North WA. It's powering a remote communication hut. In fact, this is powered by Morningstar, which is perfect for this occasion. So each site takes about 102 kilowatt hour of genZ. So that equates about 2000 amp hour. And that's being charged with 2 of Morningstar TS MPPT60. And there were 10 sites installed for this job. So that's just a touch over 1 megawatt hour of energy storage installed. On to the next slide. At genZ, we also do bespoke solutions for various organizations. The one that I'm showcasing here is for a specific requirement for a marine organization. Next slide. We've also replaced a lot of front terminal access batteries for many communication power systems with genZ battery. Next. This is a luxury houseboat in Echuca, Victoria, powered by 60 kilowatt hour of genZ, and this was installed by Sunreal Renewable Energy System. And on to the next one. This one is a containerized energy storage powered by 66 kilowatt hour of genZ, located in northwest of Queensland, and this was installed by Tropical Energy Solution. And next. And just to run it off, this is our plastic case range being used for mobile communication trailer. Next. Now, to date, we've done successful integrations with various PCS manufacturers such as Electronic, Morningstar, LTEC, and Eaton Rectifier. And in fact, we are open to integrate with different inverters or devices that you have on site. So if you do have any of those questions, feel free to drop me a contact. Now, back to Brett.
Okay, thanks, Albert. Really appreciate those application photos. You can see some of the diverse applications where these used, and it's always amazing at some of the new areas we see off-grid power systems being deployed. So to take it back and talk a little bit more about some of the products, one of the things I want to go over is some of the characteristics of lithium. We've heard about some of the features of the BMS and others with genZ in terms of how the batteries are designed. But what I wanted to talk about is when you're looking at the controller, you also want to take into account how some of these features are integrated into the batteries, because it may have an impact on the type of product or controller that you're choosing, and also how it's set up, because there's quite a few things that are very different and much improved over lead acid. The first, of course, is the BMS that was discussed, because of course balancing, providing this thermal protection, you need to know that the battery has a BMS in there, because generally the controllers will work very well with that and do not have the BMS built into the charge controller. The second is that we mentioned the area voltage range. You have to be very careful regarding stated charge settings, because the traveling of the high and the low voltage ranges for a lithium battery are much tighter than lead acid. A lot of products are configured for that wider range, and you just have to take that into account when you're making sizing decisions with the controller, because that tighter stated charge window may need to be calibrated on the product. The third, cold temperature charging. As I discussed, the lithium foldback is able to make sure that that doesn't occur. That temperature rating for that specific battery, if your application is actually impacted by cold weather, many are not, but if it is, you'll want to look and make sure that that's calibrated into the product so that that's accounted for, and when that temperature is approached, that the current is limited in the proper way. And you can see more of the details on how that is done in some of our products that have that feature, such as the ProStar MPPT. A fourth is full discharge. You can see in extreme cases, if lithium was not held back by a disconnect mechanism, and it usually is, a deep discharge to zero can actually cause damage to lithium. For that reason, many of them are extremely intelligent and have the ability to shut down before that happens. You want to be sure that if that does occur, though, that it does not strand or isolate power to the charge controller. So when you're setting your low voltage disconnect point on a charge controller, you want to be sure that that threshold is always above the disconnect point that the battery itself would do in order to protect itself. So just a little bit of correlation there is needed so that you get the best results. Obviously, extended float or standby periods are fine, because lithium does have a very low self-discharge rate. You just want to take that into account when you're looking at how often the system is going to be utilized, and lithium is an excellent choice in those extended periods where you may have your batteries at rest for long periods of time. One of the really big benefits of the high charge and discharge rate of lithium is that you can take into account a faster charge rating. I've seen many systems where we're looking at our 60 amp controller, and we may have to actually decrease the charge rate because there's a lot of power coming into the batteries. And if you don't have the largest bank with lead acid, you often will have to dial back that charge rate so that you don't exceed, maybe no more than a quarter of its amp hour capacity. And even that's on the high side. You can definitely open the throttle when it comes to charging with a lot of lithium systems. So you want to make sure to take advantage of that extra power. And then lastly, as Albert explained, yes, you will see a higher upfront investment, but generally it is easily paid for with all the benefits of the cycle life and other long-term value that's gained from the lithium choice. Okay, so keeping those items in mind with lithium, now I'll go into the very specifics of how exactly the partner program works with Morningstar, the ESP program, and show you a little bit about how we actually deploy these settings, and these curated configuration files that we have on our website can be downloaded and utilized. Okay, so here's just a little bit of an example. So generally, when you find the ESP program website, you can go to actually get a link, in this case for genZ, and those files are already available on our website right now. So if you're using the models that were covered today, you can go and actually download the MSView files and extract them, once downloaded to your desktop. And once those are extracted, then you have the ability to actually get our MS-View software, and that's the tool that is a sort of a free utility that Morningstar offers that's used to take that configuration file and write it to one of the controllers that I reviewed earlier in the presentation. Okay, so MS-View is found on our website. You download MS-View, install it on a Windows-based PC. Once that's installed, then you have your device connected with either a serial, or in some cases, you can also use an Ethernet connection if it's one of our Ethernet enabled products. And you can search for connected devices, and it will discover them either on the network or on the serial bus that's connected to the product. And then once you have a connection made, you're able to configure all of the product settings. We have a settings wizard that will actually walk you through the step of choosing all the set points. But in the case of the lithium partner program that Morningstar has, all of the settings are already pre-configured and approved by the manufacturer, so you can go right to the programming of the product. You don't have to take the steps through the process because it's already been done for you. So when you open that file that's now been downloaded to your desktop, you open that configuration file, all the settings will come up in the display wizard, and here you can see a lot of the common settings you'll see with absorption and battery temp comp already changed for lithium compatibility, and all those settings are pre-configured. This is an example of where you would actually enable the low battery foldback, which gives you a high and a low temperature range over which it will linearly reduce current so that you're not charging the battery in cold temperatures. Okay, once all those settings are confirmed, they're loaded, you get a final readout on the table, and then in this case, as highlighted, you can actually program the controller. And once that's successful, it's ready to go. You put it into the custom setting mode, and it is now configured for that battery. So as you can see, very straightforward and very easy. And again, if you have any questions, you'll find a lot of support information on our website for each of the partners, including genZ. And as always, Morningstar's tech sales team and application support team, as well as our tech support department and engineering, are all here to help you out if needed. Okay, so with that, I will kind of summarize the end of the presentation here. Again, the choice of the battery technology that you choose is really dependent on a variety of factors: your lifespan, your maintenance requirements, and of course budget. But I think what we all want to accomplish is a very reliable, long life off-grid power system. And I think that some of the information you've seen today with our partners here and with M+H providing the total system design for you, of course, will help you to achieve that. So whether it's lead acid, which is still a big part of the market, or lithium ion as it's growing in adoption, will really help to get us in the right direction. And if you have questions about the charge controller settings that you can use in these applications, you know to come to Morningstar. Okay, so with that, I'd like to thank everyone for the great overview here, really diverse webinar. And again, really happy to be part of this presentation in an industry specific and off-grid specific talk here today. So with that, I will refer back to Mark. And if we want to talk about any questions that were presented today for any of the three presenters, then we can get those answered now. Thanks.
Great, thanks, Brad. Hopefully you can hear me. This is Mark.
Yes.
I'm coming through loud and clear. So we did get a couple questions, but before I get to that, we'd like to award the prize winner of the SunSaver MPPT controller. And the winner is Quentin B. So you are the lucky winner. So we will be getting that out to you. So with that taken care of, let me just take a look at some questions that came in. And just a reminder, for those of you that might have a question, go ahead and type that into the questions chat section of your GoToWebinar interface. First question, this one looks like this is for Albert. What voltage range batteries does genZ offer?
Yep, so we offer 12, 24, and 48 volts.
Okay, very good. Thanks for that question. Thanks for the answer. And I see a question coming in from Amit. Question is, this is for Brad. which controllers are suitable for lithium batteries?
Okay, yeah, in our line, we have both our ProStar MPPT as well as PWM. Those are both fully compatible with any of the settings that I talked about today. The TriStar MPPT and TriStar PWM, and also our SunSaver MPPT controller. And lastly, also our, let's see, the SunSaver Duo technically would be as well. And if you look earlier when the handout information is available, there is a slide early in the presentation, and that will give you a single view of all the products that are compatible. It's essentially any of them that have the ability to provide customization of the set points. And the one exception I would say is that if you were intent on using the lithium foldback feature for the low temperature charging, that is only available on some of the newer products, mostly the ProStar family, ProStar PWM and ProStar MPPT. Okay, but again, in an application specific, we're happy to answer any other questions on helping you choose the right controller.
Terrific, thanks for that. Question coming in from Fabio. Question is, what is the surge current that the 48-volt genZ battery can provide, and for how long? So that would be for Albert also.
Yep, Fabio, thanks for the question. So the surge current for our 48-volt is actually limited by the circuit breaker, which is 60 amp. So that is the surge current per rack-mount module of our 48-volt genZ.
Okay, terrific. That answers that. Let's see. Looks like I have another question coming in from Ahmed. Let's see if I can drag this a little bit to see that full question. All right. Okay. For the genZ battery, what's the biggest capacity battery made or available for a 48-volt configuration? Is there any limitation on capacity?
Yep, again, let me answer that question. So the biggest capacity we've got in a 48-volt is the 3 kWh, or it's equivalent to a 60 amp hour. In terms of limitation, in terms of daisy chaining them in parallel, it's virtually unlimited. The only limitation that you have to consider is your bus bar, or your common bus that you'll have to connect to the power system, because each battery delivers up to 60 amp, and 10 batteries that's 600, 20 batteries that's 1200 amps. So that's what you have to factor in, but virtually there is no limitation.
All right, very good, no limitation. Question coming in from Keith. He says he's used the Morningstar TriStar 45. He's used the gel setting for a lithium battery. He's asking, I guess it's really for Brad, is this okay? It is within the specs for the lithium battery. He says he's wondering if that's okay using the gel setting for a lithium battery.
The gel is on the more conservative side. It's a lower one. What I would say, even though we have some specific manufacturer configuration files, as I talked about, one of the more generalized settings or suggestions I would make when you are supporting lithium with our products is primarily to disable the temperature compensation, which can be done so that is giving it a consistent regulated output, since the BMS takes care of a lot of that, and lithium's not nearly prone to the temperature range swings that lead acid deals with. And the other is to pay particular attention to the float setting, because some lithium batteries may have a very minor float setting, some do not really actually want it at all. So you would want to just look at purely an absorption level and make sure that that's fixed. So if you disable those two settings, the TriStar PWM can do well, but I still would recommend, even though the gel setting is the most conservative, I would take it a little bit further and try to customize that on the TriStar PWM if possible.
All right, very good. I have a question here. This is really for anyone who wants to answer it. The question is, in case of module failure in a battery bank, how can you identify the fault module?
Look, I'll provide some answers from genZ. So with our rack-mount module, say you've got 10 on your server rack, and say one of them has failed. the circuit breaker would actually trip, and you would actually see it, and you probably notice that you have less capacity drawing from the battery bank. So that's how you could identify there's a fault in the battery, that the circuit breaker trips.
Okay, very good. Shifting gears a little bit, we have a question for Brad here. Where does the Morningstar regulator measure battery voltage?
Well, battery voltage is, it can be measured in two ways. So by default, all of our products, of course, from the primary power connection, will take a voltage reading there as the default, okay? But because a lot of systems may have distances involved, sometimes the best wire gauge is not always used, could be a little bit insufficient, causing some voltage drops or resistance, weak connections, disconnect or MCB or fuse breakers along the way, voltage drops can be introduced into the power connection. Okay, so we'll use the power connection first, but if you wish to have the most accurate setting or sensing of the voltage on products like the ProStar and TriStar family, we have separate voltage sense lines that can bypass those voltage drop, inducers and actually get a much clearer voltage reading from the post directly. Okay, if the voltage sense terminals are used, those will take priority over the main power terminals, and those will always be used first because they're generally much more accurate. And one of the nice things about using those voltage sense lines is that you can use very small wire and run it a longer distance because they're not carrying current. The main power bus is still carrying the current, and the voltage sense readings are just like a remote of sorts. Okay, so I hope that answers your question.
Yes, it did. Very good question. Another controller question. What is your estimated service life of your TriStar MPPT controllers?
Well, all the products have a standard 5-year warranty. We would say, I guess we've targeted in the past really an ideal 15-year life is probably a good one to target. I'm happy to say that since Morningstar has been around for about 27 years now, we have proven that we've exceeded that in a lot of examples. So I'm very pleased about that. And one other thing I might touch on is if you're really interested about information such as expected failure rates, Morningstar has actually available a variety of mean time between failure or MTBF ratings, which are a good measure of predictability of service life. And those are available for a variety of our products because we cater towards industrial needs, and that's generally asked for quite a bit. So yeah, I hope that's helpful.
Very good. Another question here for Albert. Question is, can you connect your laptop to the battery BMS and run a diagnosis software and/or download log files?
Yep, sure. Thanks for the question. The answer is no. Again, the whole purpose of building genZ was we've dumped it out as a lead acid with a lithium performance. So yeah, no, we don't have a connection between the BMS to the laptop to download the data log. No, we don't have that access.
Okay, very good. Thanks for the question. Thanks for the answer. All right, I have a longer question coming in here. I want to make sure I read this right. Okay, so let's see. Okay, not too long. All right, question from Stephen. This is for Albert. The question is, what is the lowest voltage the 48 volt genZ can get to on 0% load without damaging it?
Sure. Again, thanks for the question, Stephen. I take that you meant 100% depth of discharge, and if that is, so if you hop onto our website on the data sheet product manual, it's on clause 13, appendix D. So we recommend 80% depth of discharge. So the cutoff there is about 50.38, but we can also quote 100% depth of discharge, and the lowest cutoff point is 40.4 volt. So 40.4 volt, that is the answer for 100% depth of discharge.
Okay, very good. Thanks for that. All right, looks like another a battery question for Albert. Question is, what's the best way to keep the temperature within the battery range, or how would you use the ambient temperature to control the charge cycle?
Ooh, what is the best way to keep temperature? I might have to take this offline if I could.
Sure.
I'll get back to Alan Burrows.
Sounds good. Sounds good. Let's see. All right, looks like another battery question here.
Very popular
All right.
today.
Is the maximum charge current for the genZ batteries the same as the maximum discharge current?
Is the maximum charge current the same as the maximum discharge current? Yes, that is correct.
Okay, very good. Thanks for that question. Thanks for the answer. Let's see. All right. Here's a question from Pedro. Can you connect the 12-volt genZ range in series?
Yep, very tricky question, Pedro. The only limitation we've got is the BMS that we've picked. The problem is not so much with charging, but it's not so much with discharging, but when it comes to charging, the BMS that we've picked, it doesn't really balance the cell properly when you put the two in series. So that's the only limitation we've got with the current BMS.
Okay, very good. Thanks for that question. Thanks for the answer. Right. Okay, so a question here coming from Gerard. Do the genZ battery modules have a communication bus, in other words, CAN, etc., that can be monitored to see the state of each module?
Yeah, no, we don't. In fact, we intentionally eliminate that. So typically when you commission a genZ battery, so we always recommend, in fact, it's on our installation manual, to bring the battery up as a whole, as a bank, so that all batteries are balanced, and that would avoid imbalances in the long run. So yeah, no, we don't have CAN bus
All right.
communication.
Okay, well, thanks for that answer. And back to Brad with this next question. Question is, can I have multiple Morningstar chargers connected to the same battery bank, and how many of them, and do they communicate with each other?
Okay, yeah, excellent question, since we're talking lots of parallel applications and scale. With our current line, we do not have inter-controller communication. In other words, multiple controllers do not intercommunicate with each other and synchronize. However, we do have a fairly well-written explanation of the things to take into account when you are paralleling charge controllers, because it can be done just fine. The controllers will generally, it's not required that they communicate, because generally one of them will always be the final charger to remain active, and they sort of will kind of drop out of the system, and they'll work just fine in parallel without having to talk to each other. So unless there was any issue of like data or something you were logging per product, they will play nicely. They will charge together if you generally configure them for the same battery settings. So one of the things is, Mark, if you could note that one, we could share. We have a parallel tech note for just this application that we could send to you offline. So good question. Thank you.
Sure. Okay. All right. Thanks for that question. Thanks for the answer. Looks like, let's see. Oops. Let me bounce down a little further. Looks like we answered that question. And just a reminder, there's a couple of people asked about the PowerPoint slides we use for this presentation. They're actually in the handout section. So you can go to your handout section of your user interface for the GoToWebinar user interface and go download them right now. So you got them there, as well as other documentation, implementation guides for using Morningstar with genZ. Let's see. The questions we had. Here's a question for Albert. Is there any way you can read the actual state of charge of the genZ battery, or do you just estimate this from voltage readings?
Yep, I can answer that. So with Morningstar, we are relying on the voltage reading, but with other systems, we've actually relied on shunts, and we just count on the coulomb in and out, and that would give you an estimate state of charge of the battery.
Very good. All right, terrific. Let's see. That one's a little lengthy. We'll probably have to take it offline. Pretty involved. Okay. Let's see what we got here. All right, here we go. What effect does, say, 35 degrees ambient temperatures have on cycle life, and does this affect the 10-year warranty? So that would be for Albert.
Yep, thanks for the question, Adam. Excellent question, in fact. So again, if you hop onto our website and go into our product manual, clause 3, F13, appendix D, so we have a whole table of operating parameters for a 10-year warranty. And so to answer your question, so a 35-degree ambient, you're looking at about 5,000 cycles. And again, it's available off our website. And it doesn't affect the 10-year warranty. So it still covers under 10-year warranty, but in terms of the expected cycle life, you're looking at about 5,000 cycles.
Okay, very good. Looks like another question for Albert. This might have been a follow-up question from one earlier. Gerard is asking, would it be possible to include auxiliary contacts on the circuit breaker so it could be monitored remotely to see if a module's breaker had tripped? Is that something you can answer here or take offline?
I'll take it offline if I could, please.
Okay, not a problem. Okay. All righty. And I think Brad answered a similar question to this before. Question was, how many Morningstar regulators can you run on a system in parallel? You want to take that one, Brad, or just refer them to
it's
paper?
The parallel option. We don't have a fixed number. It's you know, kind of like what Albert said. It's really just starts to become limited by the power bus and really just making it work because they're not communicating. There's not like any kind of a network ID or communication setting that's a limit. It's just more, you know, what's practical in terms of current and the DC power bus in terms of amps. So like I said, if I give an example, if you look in some of our tech and case studies on the website, there's a specific system I've seen that had 15 TriStar MPPTs on the same battery that were used together. That's the largest I've seen. So.
Okay, very good. And another question coming in, can you mix lithium and lead acid batteries in the same system? So I'll open that up to both of you, either one of you, if you want to answer that.
That's an interesting one. I would generally say that they are so different unless there was some sort of a relay that would switch between the two battery banks, that most likely the answer is no. I don't think they would perform in any way similar to each other. So I've heard of some hybrid systems where you can have like a primary and then a secondary and you can switch between the two, but I think that would take some pretty sophisticated connections, and I think I'd probably go lithium.
Okay, very good. All right, that clears that up. Another question about charge controllers. Do the MPPT charge controllers have ground fault protection?
In the case of our products, ground fault protection can be added at the system level. It is not built into any of the controllers. There's a couple ways to do that, depending on the region and the code requirements. A very simple one is a fuse bond on the ground that will actually detect current leakage and throw a breaker. That's simple. If you want a little more sophisticated and I would say a safer solution, our ground fault protection device, the GFPD, can be added either to 150 volt or 600 volt systems, which is a product that Morningstar offers, and that will use a DC DC current differential, much more similar to how a ground fault protection device works on AC circuits, such as in wet locations in your home. And that product is available and will also meet the needs of not only the code requirements, but do a lot better job in terms of accuracy and detection. And it keeps the system grounded also during an event. So yeah, those are available. But if the original question is not integrated into the controllers, it is generally provided separately in the system.
Okay, very good. And we do offer that ground fault protection device accessory that's compatible with several of our controllers. All right, so we got that taken care of. Okay, question here from Ian. This is a follow-up question. It looks like this is addressed for Brad. He's saying, questioning, to be clear, he's saying multiple parallel MPPT controllers cannot be configured as master slave. Is that true?
Let me just clarify. We do not have any type of communication link between the products. Okay, so they are, I would say, unaware of each other. So if there's a data need or something of that nature where you're measuring power and you want them to work collectively, that's not a feature of the products at this time. But they can be used in parallel on the same system. They will do so a little bit blindly of each other, but there's not any reason why that wouldn't be a successful system. And we've done it in hundreds of systems just fine. It's the primary way that a lot of telecommunication sites are supported. So again, I can provide more detail with some application notes that are on our website, but they do not intercommunicate, but there is nothing preventing them from being used in parallel battery systems just fine. And they generally will work together collectively. And then as the battery reaches a full state of charge, they generally will drop out one by one as the battery reaches 100%.
Okay, and Raj asked a question as you are answering that question, Brad. He says, what about the Morningstar hub? I guess he's talking about the Morningstar meter hub.
Yeah, the Morningstar meter hub is a product that allows the sharing of a single meter across controllers. It does not actually, while it is connected between products, it does not allow any kind of a master slave data exchange or control of charging. Okay, it is just there to actually aggregate system data and share a meter across multiple products. It also provides isolation so that there's no ground issues when you connect multiple products together. Okay, that's the role of the hub. It is not any kind of a charge synchronization or master slave device.
All right, great. That answers that question. Last question here, because we're coming up on the end of the hour. Question is, are there any problems using lithium in cold temperatures? That would be for either. I guess we can start off with Albert. Any problems with using lithium batteries in cold temperatures?
Yep, look, thanks for the question. There isn't a problem. It's just that you would expect a reduced output, and that's just purely from the chemical reaction.
And is there anything you want to add to that, Brad, as far as some of the features that are on some of the Morningstar controllers to inhibit problems with charging at cold temperatures?
I'm sorry, I was muted there. Yeah, the only impact there would be really just the cold temperature foldback. It's kind of best explained with a graph, but what happens is when you approach the lower temperature ranges, a lot of batteries can provide power, but they can't actually receive current. And I'd have to look at specifically at that, talk with Albert about genZ specs. But what the product does is if you want to limit current in those lower temperature ranges, you specify the voltage at which it should start reducing. I'm sorry, you specify the temperature that it should start reducing current, like let's say, at 5 degrees, Celsius, and then at the temperature at which it is no longer able to receive any current, like no charging whatsoever should occur, then you would enter that temperature range, let's say 0 or something similar. And then the controller will reduce current from 100 to 0% over that temperature range. Okay, so it allows you to kind of set it for how aggressive or how gradual you want it to be, but that's the primary function that we can accommodate for temperature.
Okay, very good. Okay, what I'm going to ask you to do now, Brad, is if you could advance to the next slide, which should be the thank you slide. And this has several people have asked for this contact information. So here you have the websites and the general contact information for M+H Power, genZ, and Morningstar. I think people ask for some other more specific information, and we can get back to them offline with specific email addresses. So we can accommodate that. There were just a couple of longer, pretty involved questions that we weren't able to cover. We handled just about every question, but there were just a couple that we're gonna have to take offline and email you the answers to that. Other than that, I'll leave this slide up here for just a little while longer and thank everyone for attending. Thanks to our presenters. I think things really went well. I'd like to do another one of these again sometime. This was nice. So we'll leave that up there. If you have any questions, go to the websites. Other than that, we'll see you on the next webinar, and we'll close things out. This concludes the broadcast.
Okay, thank you.